Example 4. A transformer is used to operate a 12 volt to 24 watt lamp for 240 volt AC mains. A. What turn ratio is required? B. If the efficiency is 75%, calculate the power losses. Solution. A. Turn ratio equals to turns in secondary over turns in primary, which is equals to 12 volts over 240 volts, which is equals to 1 over 20. B. Efficiency equals to power in the secondary over power in the primary times 100%, which is equals to 75%. That is 24 watts over P equals to 75 over 100, which is equals to 3 over 4. Energy losses within the transformer is equals to 32 minus 24, which is equals to 8 watts. Example 6. A transformer has a primary coil with 500 turns. Calculate the output voltage and the turns ratio with when the voltage input to the primary is 120 volts. Solution. EMF in secondary EF over EMF in primary EP equals to number of turns in secondary NS over number of turns in primary NP. ES over EP equals to NS over NP. ES over 120 equals to 2500 over 500. Making ES the subject of the formula, we have 2500 times 120 all over 500, which equals to 600 volts. Solution. Turn ratio equals to EMF in primary over EMF in secondary, which equals to 120 over 600, which equals to 1 over 5 or 1.5. 4.5 Simple AC circuit. Introduction. An alternative current AC is a current which varies periodically. The current circuit in which an alternating current flows is called an alternating circuit. E equals to EO sin W omega T. LO equals to LM sin W omega T. Figure 434a. A graph of V against T relationship, and figure B is a graph of I against time X relationship. A. The EMF varies sinusoidally with time in a rotating coil, which is given by capital E equals to EO sin 2 pi ft is equals to EO sin omega T, where capital E, EO equals to EM are the instantaneous and maximum peak value of capital E or the amplitude respectively. Omega T or 2 pi ft is equals to phase angle. B. If an alternating current I varies sinusoidally, it could be represented by the equation I equals Im sin 2 pi ft, which equals to Im sin omega t, where I is the instantaneous current at time t, Im is equals to maximum peak or value of current or its amplitude. Omega or 2 pi f is equals to the angular frequency of current. F is the frequency. Omega t is equals to phase angle, which is the state of periodically varying system at a particular time. Note: the phase difference between the voltage and the current through the RLC series circuit is represented by the equation tan phi equal to x over capital R. Root mean square RMS of AC. The root mean square RMS value of an alternating current is that direct current which produces the same heating effect per second in a given resistor. P equals to I squared R. For an AC circuit, the instantaneous power is given by P equals to IV, instantaneous value. IRMS equals to IO all over square root of 2, which equals to I efficiency. where IO is the maximum steady current. Similarly, VRMS is equals to VO all over square root of 2, which is equals to V efficiency, where RMS is the root mean square and the VO the peak value or the maximum steady voltage. Example 1. When the root mean square voltage of a source of electricity supply is given as 240 volts, calculate the peak value of the supply UME. Solution: V root mean square equals to VO over square root of 2 equals to V efficiency, but V root mean square is equals to 240 volts. 240 is equals to VO over square root of 2. VO is now equal to 240 times square root of 2, which will give us 339.4 volts. Example 2. Calculate the instantaneous value of a current if in a circuit it has root mean square value of 15.0 amp when its phase angle is 30 degrees. Solution: I equals to LO sin W omega t is equals to I root mean square equals to LO over square root of 2. IO is equals to square root of 2 I root mean square. I is equal to square root of 2 I root mean square sin omega t is equals to square root of 2 times 15 sin 30 degrees. I is equals to 7.5 square root of 2 is equals to 7.5 times 1.144, which is equals to 10.6066 ampere or 10.61 ampere approximately. Example 3. In an AC circuit, the peak value of the potential difference is 180 volts. What is the instantaneous PD when it reaches 1 over 8 of a circle? Solution: 1 circle covers 360. 1 over 8 circle covers 360 over 8, which is equals to 45 degrees. Capital E is equals to capital EM sin omega t, which is equals to capital EM sin 45, which is equals to 180 sin 45, which is equals to 180 times 1 over square root of 2, which gives us 90 square root of 2 volts. Reactance: the opposition offered to the passage of an alternating current by either the induction or the calculate or the both is called reluctance. Thus, reluctance X of an inductor L or capacitor C can be defined by the equation reactance S equals to minus amplitude of voltage across L or C all over amplitude of current through it. S equal to Vm over Im. 1. The reactance for a capacitor is given by Xc equals to Vm over Im, which equals to 1 over 2 pi Fc, where C is the capacitance of a capacitor. Impedance: the overall opposition of mixed circuit to the flow of an alternating current in a resistor and or capacitor is known as impedance. Impedance Z of mixed circuit to the flow resistor and or capacitor is known as impedance. Impedance Z is equal to V over I, which is equal to square root of in brackets SL squared plus capital R squared, where L and R are in series, which also equals to V over I, which equals to square root of in bracket S squared C plus R squared in bracket C and R in series, which also equals to V square root of in brackets R squared plus SL plus SL squared, where L